So, good morning and good afternoon. Welcome back to this new webinar at the Schlumberger Academy. Today we are talking about gas chromatography for hydrogen exploration. Is a technique using during drilling and mud logs during drilling wells for hydrogen exploration and mud logs. So gas chromatography in drilling operation, they includes and means is used to analyze gas returning from the well bore, detect and quantify like hydrocarbons, so H2S and hydrogen persistence, provide the real-time information on formation fluids and reservoir condition. We have also the setup in MudLog. The MudLog units includes, for example, and I will show you in the next slides. The MudLogs units include like this. This is a MudLog gas chromatography equipment. They includes also gas extraction systems and detection and data acquisition software. So we have also to analyze the cutting and the drilling muds for sampling, and gas trap release gas from mud, which is sent to GC analyzer. So there is also a new system that we are trying to developing that is called microgas chromatography, and is also linked to thermal conductivity detector. This is a microsystem that will posed on sampled wire line. This essential new way to hydrogen detection. So the presence of hydrogen can be indicated, for example, by biogenic gas activity, microbial degradation in shallow formation, thermogenic process from deep hydrocarbon cracking, water rock interaction, and geothermal indicators or non-hydrocarbon gas flower. Hydrogen is usually detected also through thermal conductivity detector, and in this new circuit that we are developing, we are also microgas chromatography and thermal conductivity detector. Calibrated for parts of million levels. With this new chip, it's possible to link the gas chromatography to thermal conductivity detector, and is sensitive to permanent gas. The application of micro GC using a mixed carrier gas, hydrogen is typically analyzed with is also carried out by argon or other stability gas. Argon or lower will result a decrease in sensitivity for other permanent gas, for example helium or like this. So the use of a mixture of hydrogen in helium is relieved by this system, and we are testing this new wire line. So this is a typical result of gas chromatography analysis. We have the instrument settings, column temperature, column pressure, and injection time, and we have also this kind, the chromatographer for permanent gas analysis on Moldavian basin. So we have different peak that represents the presence of, for example, methane, argon, and hydrogen. When we have a negative peak, in this case, in gas chromatography, the hydrogen is evaluated as a negative peak. So generally, this kind of positive peak represents methane or carbon dioxide, and hydrogen is represented by negative peak, because we have a negative conductivity, and also the temperature is the thermal conductivity is too low for hydrogen. Clear, the expression of the gas chromatography is linked to the practice of mud logging, and the mud log hydrogen are noted along with, for example, with change with depth and gas unit per million associated with carbon, formation type, rate of penetration, hydrogen trans may be transient peak, and also we can be detected, for example, by sustained anomalies, potential indicator factor, or gas change formation. So I show you, for example, an example of a plot of this kind of mud log that can be realized in SketchUp by Python. This is a gas concentration. In this case, we have a gas chromatography mud log view with gas ratio and also geosteering zone and seismic markers. So we have the gas concentration, the different gas concentration. We have a mixed gas situation with methane, ethane, and hydrogen. And so you can see the graph represents the part per million of the different gas. In this case, we have a high concentration, a high part per million of hydrogen. So we have gas ratio, the gas ratio of the gas ratio, that means the ratio between hydrogen and other gas in state depth. So you can see that there is just a constant ratio between hydrogen and methane. That is normal in this situation, in this study situation, but generally when we have an increase of this rapport or this ratio, we have also a peak of ratio between methane and between hydrogen and ethane. So we have also plot the lithology plus geosteering target and seismic marker. In this case, we have a link to seismic analysis and geosteering acquisition. So we have the marker A, the marker B, and the marker C, and so we have in this case the different markers evaluated by the first step by seismic, and we have also three type of lithology. So this is when we are just setting an alert for when we have a concentration of 100 plus 100 part per million, and so in this case we have, for example, different lithology, shale carbonate. We have these two kind of lithology. We can show also the whole mud log tables with that in a single row we can read the depth, the concentration, the part per million of methane, ethane, and hydrogen, and also the ratio between these three kind of gas and correlated lithology. So in this case we have sandstone, shale. It's clear that the concentration, for example, in this case of hydrogen is much more in sandstone, is much more in shale in this case, and not in sandstone. and we have a low concentration, very low concentration in this row, in this carbonate row, because are not fractured, so compact and is not a biogenic carbonate. Oh, so this is a first example, and goes on to the next step. So the next step is to the application and exploration for unconventional reservoir, for example in shale gas of tide formation. Hydrogen may indicate zone, activity zone. There will be also a presence of hydrogen in geothermal system. Hydrogen can be a byproduct of thermal reaction. But generally the hydrogen is targeting in natural Whyte hydrogen is targeting in natural hydrogen reservoir like ultrabasic rocks like serpentinite, and can help locate natural hydrogen seeps or low permeability hydrogen accumulation. So this is this kind of case. Consideration ensure proper calibration of GC system. That what we are doing during the drilling is to calibrate the GC system and control the reaction of sensitive of temperature. Account for drilling activities or tools interaction, they may artificial produce hydrogen, because there is also this kind of risk, this kind of factor. So this is a typical equipment of gas chromatographer mud log. In next page we are showing we show also a fast result, the first result of mud logging online gas chromatography. There is the peak that they are reading, and we have also the plot of gamma ray resistivity and gas chromatography in the same plot with mud logs. So we have the presence of this kind of gas detected by the mud logs, by the peak of mud logs. So we have generally the presence of methane along all well drilled, but we have the presence of also more complex organic molecular and weighted molecular like this. So we have also the estimation of deviation in drilling path from 50-50 to 750 in this case, and the presence of hydrogen is linked to this part. So we are showing also a case of study of field in Mali. In Bukarud field, the formation found in this area covered a rather long time period from Archean to Quaternary. This is a sketch of geology in this case. The oldest formation are located to the south of the study area and are a part of the so-called Leon range. The formation are mainly composed of plutonic and volcanic sedimentary basin. So the first log activity, in this case we have a log activity with the gamma ray and gas logging, that I show you a synthetic graph. In this case we have the gamma ray and neutron log and gas logging. So that gas logging underlines the presence of high concentration, hydrogen concentration in first layers, dolerite layers, and we have also the presence of hydrogen gas, not only in carbonate but also in sandstone. In this part we have white peak of sandstone, and so we have two type of hydrogen reservoir. We have also the picture of gas log with core rocks picture in depth, so with all formation drilled, different data used to identify and characterize the hydrogen, the different formation, the hydrogen accumulation zone between 0 to 530 meters. We have 3 tracks and also the density and the neutron porosity in limestone matrix scales, the formation nature and the concentration of hydrogen from gas logging. So as just we say, we have identified two types of reservoir, one in carbonate, one in sandstone reservoir. The first is carbonate reservoir. So the carbonate reservoir is underlying a high concentration of hydrogen with around 100 parts per million. This is a karstic reservoir. Also we showed the boreal image, and we have the main carbonate. We make macroanalysis of section. In this case, the karstification is probably due to acid fluid related to the CO2 degassing during the magmatic setting of the doleritic seals. Indeed, karstification due to meteoric fluid is not probable, since the upper part of carbonate is not karstified. The karstification only make successfully occurred close to dolerite intrusion. This phenomenon is underlined to study the samples of rocks. The core section close to dolerite intrusion show cracks, which are evidence of carbonate dissolution. So the marble zone have been shown in this plot, and marble can be interpreted as related to a contact metamorphism which we have during the intrusion of the seal. The karstic nature and the presence of aquifer system are also confirmed by acoustical barrel image. So this is the acoustical barrel image that show you the presence of karstic aquifer, and large void are observed, and we have also large void. In this case, you can see this large void at different levels of carbonate reservoir. It's like a sacs of, like a bubbles of, like a bubbles for hydrogen storage. So the second type of reservoir is in sandstone. We are here. The sandstone is in this, and the first dolerite is this, with precipitation and contamination of other minerals and karstic reservoir. The second reservoir is in sandstone, and it corresponds to a hydrogen-rich zone with presence of fine iron sediments in sandstone, and so also petrophysical and microscopical analysis confirm that in some wells, there are fine minerals that correspond to serpentinized mineral that has been recrystallized after initial phase of partial dissolution of quartz grain. Associated to these small minerals, we have also a second phase of recrystallization of quartz in the porosity. This indicates transport by an erosive agent. That means there was an erosive agent that make this erosion and redeposition like wind or water. And we have also the presence of helium in some samples. So we have some indicators that we have this phenomena of re-erosion and re-deposition. The porosity values show in this Hydrogen presence by logging tools. So finally we have a scheme of presence of hydrogen in different layers. We have, and also the correlation to neutral logs. When we have an increase of value, a positive value of neutral logs, we have the presence, we have a correspondence to gas chromatography. So neutral logs high value correspond to presence of in this interval of depth, the presence of hydrogen. So they will call also hydrogen logs. Is also linked to a sensitive sonic log value. So we have a good correlation specific with neutral log, but also with sonic log. So in karstified reservoir of the Bangulad field, there is indeed a free hydrogen gas. This is the final conclusion, and it is been coherent that correlated to the neutron porosity logs. This is the final one of the final result. So furthermore, also the sonic logs and a decrease of p-wave velocity in the main reservoir zone is also observed to the presence of gas phase. So when we make sonic log and the p velocity is too low, or we have a decrease of p velocity, we have a presence of gas. This is a geophysical and petrophysical application to the hydrogen exploration. The final results showed this situation, and the degassing of initial sulfide hydrogen in cast carbonate. In cast carbonate we have initial degasses of this, and we have a first state dolerite seal that trapped all free gas present in sandstone reservoir. So we have different situation because the carbonate is casted, and we have much more fracture and vacuous that is like a bubble for the hydrogen gas. And the second situation is too different because we have dolerite that trapped the sandstone reservoir, and in this case around this depth with noticed also pressure. We have a particular situation because we have a free gas in sandstone porosity, but around this depth, around 1800 meters depth, so the pressure makes the solubilization in saline aquifer solubilized. The hydrogen was solubilized in water. So it's complex to make to planning extraction. We need two different techniques to extraction because we have casted the reservoir and free gas and also solubilized in water. Finally, we can distinguish three types of reservoir: casted reservoir with vacuum sac bubble. Second reservoir is free gas in porosity sandstone, and the third reservoir is deep sandstone reservoir with hydrogen solubilized water. Around the depth of 1,100 we have the basement. So this is the complex situation, the complex geological situation of study in Mali bunker wood field. Finally, we have the first production. We discovered this. The first production is around this value, this volume value of hydrogen by days. Thanks for attention, and so in next appointment I think we'll talk about the last hydrogen technique, the last hydrogen logs technique, that is mass spectrometry during drilling, also during logging while drilling and mud while drilling, to detect trace of hydrogen during drilling. Today are focused on gas chromatography.